Hi there. Thanks for joining us today. We are looking for a Flutter developer to join our team, and based on your profile, you have about a year of professional experience. To start things off, why don't you just give me a high-level overview of what Flutter is and why you think it is a better choice than going with traditional native development for iOS and Android?
Thanks for having me. To put it simply, Flutter is an open-source framework created by Google for building beautiful, natively compiled applications for mobile, web, and desktop from a single codebase. In traditional native development, if a company wants an app on both platforms, they usually have to write the code twice, once in Swift for iOS and once in Kotlin or Java for Android. This means two different teams and two different codebases to maintain. With Flutter, I can write one set of code that works on both.
That is the main selling point for most businesses, definitely. But from a technical standpoint, does it feel like a compromise in performance compared to native?
I don't think it is a compromise. One of the biggest advantages is how Flutter handles rendering. It uses its own rendering engine, called Impeller or Skier, to draw every single pixel on the screen directly on a canvas. It does not rely on a bridge to communicate with the native platform UI components at runtime, which is where some other cross-platform frameworks struggle. Because it communicates directly with the GPU and compiles Dart code into native machine code using ahead-of-time compilation, the apps start quickly and the animations are very smooth. Plus, as a developer, the hot reload feature is a huge win because I can see my changes instantly without restarting the whole app.
Let's dive a bit deeper into the architecture. You mentioned the rendering engine, but for someone working in the code, Flutter talks a lot about trees. Could you explain the difference between the widget tree, the element tree, and the render tree?
Sure. This was one of the more challenging concepts for me to grasp when I first started, but it makes sense once you see how Flutter optimizes performance. Essentially, there are three parallel trees. First, there is the widget tree. This is what we, as developers, interact with. The widget tree is basically a lightweight configuration blueprint. It describes what the UI should look like. Because widgets are immutable, they are destroyed and rebuilt very frequently.
If they are being destroyed and rebuilt all the time, wouldn't that be incredibly expensive for the processor?
Exactly, and that is why the element tree exists. The element tree acts as the manager or the glue between the blueprint and the actual screen. While widgets are temporary, elements are more persistent. The element tree keeps track of where a widget is located and manages its lifecycle. When a widget is rebuilt, the element compares the new widget with the old one and only updates what is necessary.
And where does the render tree fit into that?
The render tree is where the actual heavy lifting happens. It contains the render objects. These are the objects that calculate the actual sizes, handle the layout constraints, and paint the pixels on the screen. So in short, if I had to summarize it, the widget tree is the plan, the element tree is the coordinator, and the render tree is the actual implementation.
That's a clear explanation. Now, building on that, let's talk about rendering performance. When we talk about recomposition in Flutter, what exactly is happening and how do you ensure the app stays performant?
Recomposition happens when a widget's state changes, which triggers the build method to run again. The main goal for high performance is to minimize the number of widgets that need to be rebuilt. The danger is that when a parent widget rebuilds, all of its children usually rebuild too by default. If you are rebuilding large parts of the UI that haven't actually changed, you are wasting CPU and GPU cycles. This is what leads to dropped frames or that laggy feeling in animations.
So, as a junior developer, what are some of the practical things you do to prevent that?
I try to localize state changes as much as possible. Instead of calling setState in a huge parent widget, I try to push the state down into the smallest possible widget that actually needs to change. That way, only that small portion of the tree is marked as dirty and updated. I also use constant widgets wherever possible. If a widget is marked as const, Flutter knows it never needs to be rebuilt, which saves a lot of work during recomposition.
Let's shift gears to the language itself. Dart has introduced sound null safety. Can you explain what that is and how it actually changes the way you write your code day to day?
Sound null safety is basically a guarantee from the Dart compiler that a variable cannot contain a null value unless you explicitly tell the language that it is allowed to be null. In the older versions of Dart, any variable could be null at any time, which led to those classic null pointer exceptions where the app would just crash at runtime because you tried to call a method on something that didn't exist.
I remember those days. It was a constant battle of checking if things were null before every line. How does the new system fix that?
Now, the type system distinguishes between nullable and non-nullable types. If I declare a variable as a string, it cannot be null. If I want it to be nullable, I have to declare it as string with a question mark. The compiler then forces me to handle the null case. If I try to use a nullable variable without checking it first, the code won't even compile. This shifts the discovery of crashes from the user's device to my development phase. It makes the apps much more stable, and it actually helps performance because the compiler can optimize the code knowing certain values will definitely never be null.
Speaking of the compiler and the structure of the app, let's talk about BuildContext. You see it in almost every build method. What is the actual significance of the BuildContext parameter?
BuildContext is essentially a handle or a reference to a widget's location within the overall widget tree. Since Flutter builds the app as a nested hierarchy, the BuildContext tells Flutter exactly where a specific widget is positioned relative to others.
Why is that location so important? Why can't a widget just be an independent object?
Because widgets often need information from their parents. For example, if I want to use the app's global theme or access the screen size via media query, the widget needs to look up the tree to find those providers. The BuildContext is what allows the widget to search upwards through its ancestors to find that data. Without it, a widget would be an isolated piece of UI with no way to interact with the rest of the application structure.
I see. Now let's talk about state. This is a core part of Flutter. Could you explain the primary difference between a stateless widget and a stateful widget, and give me a real-world example of when you would choose one over the other?
The main difference is whether the widget can change its own state during its lifetime. A stateless widget is immutable. Once it is built, it cannot change its appearance or data on its own. If it needs to change, the parent widget has to rebuild it with new information. I would use a stateless widget for things like a custom icon, a label, or a static profile card that just displays data.
And the stateful widget?
A stateful widget has a separate state object that persists. This allows the widget to track internal data and trigger a rebuild of the UI using the setState method. For example, if I'm building a login form, I would use a stateful widget. I need to track what the user is typing into the text fields, and I might need to show a loading spinner when the login button is pressed. Those are internal changes that happen while the widget is on the screen, so it needs to manage its own state.
You mentioned login forms. Let's talk about user input. What are the most common methods you use for handling user input in Flutter?
The two most common ones I use are text fields and buttons. Text fields allow the user to type in strings, and I usually use a TextEditingController to manage the text and listen for changes. Buttons like elevated button or text button are used to trigger specific actions when the user taps them.
When those buttons trigger actions, they often involve things like API calls. How do you handle those asynchronous operations in Dart?
In Dart, we use the future object. A future represents a value or an error that will be available at some point in the future. It is essential for tasks that take time, like downloading data from a server or reading a file from the local disk. If we did these tasks synchronously, the entire UI would freeze until the task finished, which would be a terrible user experience.
And how do you actually write that code?
I use the async and await keywords. I mark the function as async, and then I use await before the call to the future. This tells the program to pause that specific function and wait for the task to complete before moving to the next line, but it doesn't block the rest of the app from running. If I don't want to use async await, I can use the then method to define a callback that runs once the future completes.
Let's move into data handling. Imagine you have a list of 1,000 items coming from an API. If you put them in a standard list view, the app might lag or crash. What widget would you use instead and why?
I would definitely use List View Builder. A standard list view tries to render every single item in the list all at once, which consumes a massive amount of memory if you have a large dataset. List View Builder uses a concept called lazy loading. It only creates the widgets that are actually visible on the screen at that moment. As the user scrolls, it destroys the items that move off-screen and builds new ones that are coming into view.
That handles the memory, but are there other ways to optimize a long scrolling list to make it feel even smoother?
Yes, there are a few things. First, I make sure not to do any heavy computations or API calls directly inside the build method, because the build method runs frequently during scrolling. I pre-process the data before it hits the list. Second, I use constant widgets for the list items where possible. Also, if the items have a consistent height, using a fixed extent or calculating a fixed item height helps the scroll controller calculate the total length of the list without having to render every single element first.
You mentioned that Flutter rebuilds widgets frequently. Sometimes when you have a list of items that can be reordered or deleted, the state gets mixed up. How do you handle that?
That is where keys come in. In Flutter, widgets are just blueprints. When you change the order of a list, Flutter looks at the widget type to decide how to update the screen. If you have 5 widgets of the same type, Flutter might get confused about which state belongs to which widget, and you might see the wrong data staying on the screen after a deletion. By using a key, I give each widget a unique identity. This tells Flutter exactly which widget is which, ensuring the state stays attached to the correct widget even if its position in the list changes.
You mentioned keys. There are different types like value key and global key. When would you use one over the other, and are there any performance concerns?
I use a value key when I just need to uniquely identify a widget among its siblings, like in a list. It is lightweight and very efficient. A global key is much more powerful. It allows a widget to be uniquely identified across the entire app, regardless of where it is in the tree. I usually use a global key if I need to access a widget's state from a completely different part of the app, or if I need to move a widget from one part of the screen to another without it losing its internal state.
Are there any downsides to using global keys?
Yes, they are much more expensive. Global keys require the framework to manage a global map of keys and perform more complex lookups. If you use too many of them, it can definitely slow down the app. I always try to use value keys or other local keys first, and only reach for a global key if it is absolutely necessary.
Let's talk about testing. As a developer with a year of experience, how do you approach testing your Flutter apps? What are the different types of tests you use?
I use 3 main types of tests. First are unit tests. These are the fastest and simplest. I use these to verify a single function, a method, or a business logic class in isolation. No UI is involved here. Then there are widget tests, which are also called component tests. These allow me to test a single widget and its interactions. For example, I can simulate a button tap and verify that a specific text appears on the screen.
And the third type?
Integration tests. These are the most comprehensive. They run the entire app on a real device or an emulator. This ensures that all the pieces work together and that the end-to-end user flow, like signing up and then navigating to the dashboard, is successful.
That's a good spread. Now let's go into some more advanced territory. Most developers stick to the standard widgets, but sometimes you need something completely custom. How would you implement a custom render object, and when is that necessary versus just using custom paint?
To implement a custom RenderObject, I would create a class that extends RenderBox. I have to override the performLayout method to determine the size of the object based on the constraints coming from the parent, and I have to override the paint method to handle the actual drawing. I also need a RenderObject widget to link the widget tree to the rendering tree.
Why go through all that trouble when custom paint is available?
Custom paint is great for drawing shapes or graphics, but it relies on the parent to define its size. If I only need to draw something, custom paint is enough. But if I need precise control over the layout phase, I need a RenderObject. For example, if I'm building a very complex custom scrolling effect, or a grid that has logic that standard layout widgets can't handle, a RenderObject allows me to tell the parent exactly how much space I need or how to position children based on complex logic. It is much more performant for high-complexity layouts.
Let's talk about project structure. As an app grows, the pubspec YAML can become a mess and the folder structure can get overwhelming. How do you manage dependencies and organization in a larger application?
For dependencies, I use the pubspec YAML, but I try to be very intentional about versioning to avoid breaking changes. To keep the project organized, I prefer splitting the app into smaller local packages or modules instead of having one giant folder. For example, I might have a separate package for data services, one for the UI component library, and one for the core business logic.
How do you link those local packages together?
I use path dependencies in the pubspec YAML to link those local folders. This helps in keeping the code decoupled. I also use dependency injection tools to manage how these packages communicate. This way, one part of the app doesn't depend too heavily on the internal implementation details of another part.
Let's go back to the relationship between widgets and elements for a second. You mentioned them earlier, but could you explain why Flutter specifically chose this separation? Why not just have one class that does everything?
Because of performance. As I mentioned, a widget is just a lightweight configuration. It is a blueprinter. If the widget class also had to handle the actual rendering and the state of the pixels on the screen, it would be a very heavy object. Since widgets are destroyed and recreated constantly, the overhead would be massive. By separating them, the element class acts as the persistent manager. It can compare the new widget blueprint with the old one, and only update the specific parts of the render tree that actually changed. It avoids rebuilding the entire rendering tree every time a single variable changes, which is what makes Flutter so fast.
That's a very solid understanding of the internals. I want to touch on BuildContext one last time. You said it helps widgets find information from above them in the tree. Can you give me a specific example of how that works with theme data?
Sure. If I have a widget deep in the tree, and I want it to use the primary color defined in the app's main theme I call theme of context, the context is the key here. Flutter uses that context to start at the current widget's position and look up the tree, parent by parent, until it finds the theme widget that provides the theme data. If the context wasn't passed, the widget wouldn't know where it is in the hierarchy, and it would have no way to search for that theme data.
It sounds like you've spent a good amount of time digging into how the framework actually works, not just writing UI. To wrap things up, do you have any questions for me about the team or the projects you'd be working on?
Yes, I do. I am curious about how the team handles state management. I have used a few different approaches in my projects, but I would love to know what the standard is here, and if there is a specific architecture, like BuildContext or provider, that the team prefers.
That is a great question. We actually use a mix of provider for simple state and BuildContext for our more complex business flows to keep things separated. We can definitely dive deeper into that if we move to the next stage. Well, it has been a pleasure talking with you. You have a very strong grasp of the fundamentals for your experience level. We will be in touch soon.
Thank you very much for your time. I look forward to hearing from you.